All right, today we're going to peel back the layers of our planet. We're going to look at the invisible engine that powers, well, everything, from a single forest all the way up to the entire globe. So let's just dive right in.
Now that might sound a little bit like a riddle, right? But the answer is actually the key to understanding how all life on Earth is connected in one massive, incredibly intricate network. To find that answer, we first need to get a handle on the stage where this whole drama plays out.
And that stage, well, that's what we call an ecosystem. Now, it's a word we hear all the time. But what does it actually mean? What are the essential moving parts?
So what is an ecosystem really? At its heart, it's basically any community where living things are interacting with their non-living environment. And the scale doesn't really matter here. A puddle in your backyard can be an ecosystem just like the Amazon rainforest is. The real magic is all in that interaction.
And what's so fascinating is how these two sides are in this constant conversation. You have the biotic or living parts, the plants, animals, fungi, and they depend completely on the abiotic, the non-living parts. Things like sunlight for energy, water to drink, soil for nutrients. It's this continuous back and forth that actually makes the whole system tick.
Okay, so how does this system actually run? Well, like a lot of things, it runs on energy. And the story of that energy, it's really the story of who eats who. This is a perfect, simple way to see how that power flows. I mean, it all starts with the sun, right? Primary producers like plants do this incredible thing where they capture that solar energy. Then along comes a primary consumer, a herbivore like a rabbit, and it eats the plant. Boom, that energy gets transferred. Then our fox from the beginning eats the rabbit, and the energy moves up another level. And finally, maybe a top predator, like a hawk, eats the fox, putting it at the very peak of this particular chain. And you know what's cool? We can actually measure all this energy that's stored up at each level. The concept is called biomass. It's really just the total weight of all the living stuff, the plants, the rabbits, the foxes, in a specific area. It's basically a physical stand-in for all that stored energy. So when you actually chart that biomass, you always get this pyramid shape. And here's the crucial point. A huge amount of energy gets lost at every single step. Think about it. Animals burn energy just moving around, breathing, keeping warm. So only about 10% of the energy from one level actually makes it to the next. And that right there is the simple reason why there's always way more grass than rabbits and way more rabbits than foxes. But what happens when things die? Well, that's where the real unsung heroes of the ecosystem come in, the cleanup crew. Decomposers, we're talking fungi, bacteria, worms, they are the planet's absolute top-tier recyclers. They break down all the dead material, and in doing so, they return those vital nutrients back to the soil for plants to use all over again, which completes the whole cycle. You can even find fungi in England's Sherwood Forest with creepy names like Dead Man's Fingers doing this incredibly important job. Okay, so we've been looking at this on a pretty local level, but these exact same rules apply on a massive planetary scale. So let's zoom way out and see how these principles build up to create Earth's giant ecosystems. And these giant global-scale ecosystems, well, they have a special name, biomes. A biome is just a huge area with a pretty similar climate, which means it has similar plants and animals that have all adapted to live there. You can kind of think of them as the world's major ecological neighborhoods, and they're all defined by two main things, temperature and rainfall. So let's take a quick world tour. Down near the equator, you've got these hot, wet conditions that create tropical rainforests, and they are just bursting with the most diverse life on the planet. Move away from there, you'll find hot, dry deserts, or these huge, sweeping grasslands. Then you have temperate forests, like in Europe and North America with 4 distinct seasons. Go even further north, and you're in the cold, snowy coniferous forests. And finally, up at the poles, you hit the tundra, where the ground itself is just permanently frozen solid. Each one of those biomes is like a finely tuned engine that's been developing for millennia. But here's the thing about a finely tuned engine. These delicate balances can be broken. And a lot of the time, human activity is the reason why. 3 billion. That's a huge number. And that's how many people on this planet rely on fish as a major source of protein. But with modern industrial fishing, we're literally pulling fish out of the ocean faster than they can possibly reproduce. This puts an absolutely enormous strain on marine ecosystems, and it threatens to make entire food chains just collapse from the bottom up. Another way we throw off this balance is by moving species all around the globe, sometimes on purpose, sometimes not. An invasive species is basically an outsider,
an organism introduced to a new home where it has no natural enemies. And without those built-in checks and balances, well, its population can just explode. A perfect and kinda crazy example is the Chinese mitten crab. It literally hitched a ride to the UK in the ballast water of big ships. So, in its new home, it has almost no predators. And as its numbers boomed, it started causing really serious problems, burrowing into riverbanks, causing them to collapse, all while outcompeting the native species for both food and shelter.
And sometimes these introductions are done on purpose, with absolutely disastrous results. Back in 1935, Australia intentionally introduced the cane toad, thinking it would control a beetle pest in the sugarcane fields. The problem? The toads didn't care about the beetles at all. Instead, their numbers just exploded. And because the toads are highly poisonous, they started killing off huge numbers of native predators that tried to eat them.
The source material puts it with this incredible, dry understatement. The plan was unsuccessful. Unsuccessful? This was an ecological catastrophe that Australia is still dealing with almost a century later. It's a perfect, tragic example of the law of unintended consequences.
So, okay, we've seen how these systems get built, and we've seen just how fragile they can be. And this brings us to the most important question of all. Why does any of this really matter?
Because it's all connected. It really boils down to one simple, powerful idea. Every single component, from the fungus in the soil to the predator at the top of the food chain, from a tiny local pond to the entire global climate, is part of one vast, interconnected system. You pull on one thread, and the entire web trembles.
The ecosystems of our world function on this incredible, delicate balance, one that's evolved over millions and millions of years. And understanding that really leaves us with one last critical question. Now that we've seen how the balance works, what is our role in helping to maintain it?